Hello and welcome. In this lesson, we'll talk about velocity and acceleration. We'll explore them as applications of higher order derivatives. Remember that velocity measures how fast the position is changing. So if the function that represents position is indicated by st, then we'll say that velocity will be the rate of change of position s prime t in prime notation or ds dt in Leibniz notation. The acceleration, on the other hand, measures how fast the velocity is changing. As a result, we'll say that the acceleration is measured as the first derivative of velocity or the second derivative of position. In Leibniz notation, we say that acceleration equals dv over dt or second derivative d squared s dt squared. Let's take a look at some examples. In the first example, we are going to take a look at how to determine an equation for velocity and acceleration in a certain motion that is described by a position equation. So here goes our position equation. St equals 1 over 6 t cubed plus half t squared plus t. So to find velocity as function of time, we'll say that vt equals s prime t, which would equal, simply apply the power rule. So coefficient 1 over 6 times the power of 3, that will give 1/2. T will be to the power of 1 less than 3, so that's 2. Then plus, we have coefficient 1 over 2 multiplied by 2, which equals 1. We don't have to write the coefficient 1, so simply write t, and then to the power of 1 less than 2, which is 1. And then plus the derivative of the last term, which is t, would equal 1. So this represents the velocity equation for this particular motion. Now, if we want to determine the acceleration as a function of time, we said that we are going to differentiate the function v, which can also be seen as the second derivative of position. So we'll use this equation for acceleration, and we'll say that it equals 1 over 2 times 2, which is 1, t to the power of 1 less than 2, so t to the power 1. We don't have to write power of 1. And then plus the derivative of t to the power of 1, which is simply 1, and the derivative of 1, which is 0. So the acceleration equation is at equals t plus 1. The next question will try to evaluate the initial velocity. So pay close attention to the word initial. Initial means at time equals 0, which means that we are trying to evaluate velocity at 0. Now we know that velocity is 1 over 2 t squared plus t plus 1. That's the equation we obtained for it. So at 0, this will turn into 1 over 2 0 squared plus 0 plus 1. So we'll say that v0 equals 1 meter per second. In a similar way, we'll evaluate the initial acceleration, which means that we're trying to find a t at time equals 0. So we'll use the acceleration equation for it, and we'll write acceleration equals t plus 1. So at 0, this would equal 0 plus 1. So acceleration equals 1 meter, careful with the notation, per second squared. Now in the next question, we're asked to find velocity, position, and acceleration at time equals 2 seconds. So I will write the equations of each unknown here. So we'll say st equals 1/6 t cubed plus half of t squared plus t. Vt will help us find the velocity. So the equation is 1/2t squared plus t plus 1. And at equals t plus 1. So by now we know the equations of all these three quantities. All we have to do is evaluate time equals 2 seconds. So we're finding S, V, and A at 2 seconds. Which means that wherever you see the variable t, you replace it by 2, by number 2. So this would equal 1/6, 2 to the power of 3, plus 1/2, 2 to the power of 2, plus 2. So that would be 8/6, which is 4/3, plus 4/2, which is 2, plus 2. So 4/3 plus 4 would be 4/3 plus 12/3, which amounts to 16/3. That means that the position will be 16.3 meters away from the initial position. At 2 seconds, the velocity will be t squared plus t plus 1. So that means 2 squared plus 2 plus 1. 2 squared is 4, plus 2, 6, plus 1, 7. So we'll say that velocity is 7 meters per second. And same thing with acceleration. We're following the acceleration equation, and we'll substitute t by 2. So that would give 3 meters per second squared. So very careful with the unit measurements. So we got S at 2, we got V at 2 seconds, and A at 2 seconds. Okay, so now we're going to move on to one very important